All right, this one wants us to simplify this expression. And you can see here we got 1 minus, that's a x squared right there in case that didn't come out very well. But let's give ourselves some space. Now, just like we've said before, when we see a problem like this one, it's nice to just actually kind of focus on one at a time. One part at a time, I should say. So we're going to look at this expression. I like to start with the numerators, so that's what I'm going to work with from the beginning here, okay? So let's see if I can give myself a decent line. That's good. Okay, now what I notice from what we have to start with is that I've got a 1 plus 15 over x plus 56x squared. And I've got an x and an x squared, which means that really, and this may be helpful to see the 1 as 1 over 1, because remember, what we want at this point is a common denominator so that I can actually just kind of combine everything into one fraction like this. Okay, so I've got a 1, I've got an x and an x squared. So for example, the first term here, it's missing, well, an x squared. Okay, so I'd have to take the 1, multiply it by x squared, but if I do it to the denominator, I got to do it to the numerator. And this is kind of my target denominator, right? Like right now I know that I'm expecting my denominator to be x squared. So, but this x, it's missing another x, so I'm going to show it as just times by x. But if I do it to the denominator, I'm going to do it to the numerator. Now, you could show this as x squared if you wanted to. I'm just going to keep it like this because I understand that x times x is x squared. Now, the last term here, 56 over x squared, yeah, it's got an x squared denominator. And if you need to see the ones, then feel free to do it, but I don't really need them. So now that all my denominators match, I'm going to rewrite the numerator as it was, and that would be x squared. And then we also had a positive 15x. And then a positive 56. If you weren't sure that these were positive, we got the plus signs there, okay? Now you could say, well, can you factor this out? Yeah, you could. Well, you know what? Yeah, let's go ahead and do that right now. What the heck? If you wanted to wait till later, like you wanted to work with the denominator first, feel free to do that. It's not like it's going to change anything, but right here, at least I know I have a denominator of x squared. What I'd like to do is take that numerator and just change it into two binomials. And I can do that pretty quick because the leading coefficient is a 1 right there. So from here, since my leading coefficient is a 1, I'm just looking for two factors of 56 that add up to 15. And I know that that would give me, well, I'd have to use 8 and 7. Again, 8 times 7 is 56, but 8 plus 7 is 15, the middle coefficient. I'm going to take the shortcut here. I know the leading terms are x's, but then the other two terms are the two factors of 56, positive 8 and positive 7. So that's about as much as I can do with the numerator. So now I'm gonna go look at the denominator. If you need to cover up the numerator, then do that. I'm gonna keep it uncovered though. So at this point, I'm working with just that denominator, and I see I've got a 1. I'm gonna make it 1 over 1 because I have my x squared denominator. So what I'd like to do is force this denominator to be also an x squared, and I will do that by multiplying the 1 by x squared. But if I do it to the denominator, I must do it to the numerator as well. So from here, I know I have a common denominator of the x squared. Okay, and that was what was planned. In the numerator, I've got the x squared, and then we just keep the minus sign with the 64 right there. Okay. Well, now what do we do? Well, we should look to factor anything that we can. Not particularly this x squared, but the x squared minus 64. That looks to me like it's a difference of squares. So I'm going to take that denominator there, and I know that that x squared denominator in the denominator will stay. But I'm expecting that difference of squares, and that's where I need this to be split into two binomials, right? So it's x squared minus 64. Again, we should have subtraction and addition between the two terms in both binomials. The first term is just going to be the x there, and then 64 would be 8 times 8, so I've got an 8 and an 8 there. And so this is my new expression, right? So at this point, what I'm going to do is I'm going to take that expression and I'm going to change it then into a division problem. So that means that I just need to take, and I'll use some technology here, I'm going to take the numerator, which is x plus 8 times x plus 7 all over x times x squared. and then since it's a fraction, it would be division of the denominator, which at this time is x minus 8 times x plus 8 all over x squared. But again, the whole point here is that we don't want to divide the fraction. So what I'm going to do is I'm going to change division to multiplication and then flip that second fraction right there. So the first one, again, it just stays the same. So I just bring this down. It's being multiplied, though, by the new fraction having reciprocated the second one. And this is what I have now there. Okay, so we now, since we have multiplication, we can start looking for any matches in the numerators and denominators. And when we find those matches, we can take them away as phantom ones, right? For example, the x squared in green, I see a match with the x squared in red. But also, I see an x plus 8 here in purple, which matches this x plus 8 in the denominator of the second fraction in orange. Now, if there was anything else that I could take away as a phantom one, then I would. But I'm not seeing it. So I'm going to have to rewrite this, but by taking away all the phantom ones, I should end up with an individual fraction. So I see I've got that x plus 7 in parentheses there, in purple, in the numerator, and then all that I see left in the denominator is the x minus 8 in parentheses as well. Okay. Now I'll clean this up because I can. I don't really want to see those parentheses. It just looks a little better without them. And this right here is my final expression, having simplified from the factoring of all this stuff from the beginning. But it simplifies. When we talk about simplification, we are talking about this cross simplification, which is really just making a bunch of phantom ones there.